The night Galileo turned his telescope towards Saturn, he wrote to the Duke of Tuscany that the planet was not alone, that it appeared to be composed of three bodies, almost touching, never moving relative to each other. 2 years later, the companions vanished. He had no explanation. There was no collision, no trajectory change, nothing in the mechanics he understood that would account for the disappearance. He wrote that he did not know what to say about something so surprising, so unlooked for, so novel. And then, in genuine bewilderment, not metaphor, not literary flourish, but the actual confusion of a man who prided himself on not being confused, he wondered whether Saturn had consumed its own children, the way the god Cronus had in the old stories, swallowing his offspring to prevent being overthrown. He was looking at rings. He did not know that. His telescope could not resolve a flat disk at that distance. What it showed him looked like a planet with two attendants pressed close on either side. And then, 2 years later, nothing, just Saturn, alone again. What had actually happened was this. The rings had tilted edge onto Earth. They are almost impossibly thin. Across their full width, they span nearly 280,000 kilometres, a distance that would stretch most of the way from Earth to the Moon. But in most places, their thickness is between 10 and 100 metres. At the scale of their width, that is not a line, it is far less than a line. If you scaled the rings down to the size of a sheet of paper, they would be many times thinner than the paper itself. When the Earth's angle of view lines up with the ring plane, they vanish, not because anything happened to them, because they were always almost not there. Galileo died in 1642. He spent the last 32 years of his life with a mystery he could not resolve, watching Saturn's companions appear and disappear on a cycle he could not explain, encoding his observations in anagrams and sending them to courts and scholars across Europe, protecting a priority claim on something he did not yet understand. He knew he had found something real. He could not name it. Christian Huygens named it in 1659. He had spent 4 years working through the geometry after observing Saturn with a better telescope in 1655. His conclusion, published in a book called Systema Saturnium, was precise and complete. Saturn was surrounded by a flat ring, tilted to its orbital plane, solid, touching nothing, explaining both the companions and the vanishings in a single elegant structure. The ring was edge-on every time the companions disappeared. It was open, tilted toward Earth, every time they returned. That was all. There was no mystery in the mechanics once you understood the shape. What Huygens could not have known, what no one could have known, for another 366 years, was that the shape was temporary. The rings were not always there. That is the fact this story turns on, and it is the fact that almost every version of this story mentions and then moves past too quickly, as if it were background rather than the point. The rings were not always there. For most of Saturn's 4.5 billion year history, the planet looked nothing like the Saturn that Galileo saw, that Huygens decoded, that every child draws when they draw a planet. For most of its existence, Saturn was just a planet tilted, massive, banded with storms, orbited by dozens of moons, but ringless, distinguished by its size and its gravity, and nothing else. The rings appeared at the outside 400 million years ago. Current best estimates, built from data gathered in the final orbits of the Cassini spacecraft before it destroyed itself in Saturn's atmosphere in September of 2017, put the rings closer to 100 million years old. Not 400 million, 100 million. The difference matters because 100 million years ago, the dominant land animals on Earth were dinosaurs, not the early ones. The fully developed Cretaceous fauna, theropods and sauropods in a world so different from ours that the continents themselves were in different positions. The rings of Saturn did not exist when the first Jurassic sauropods were leaving footprints in what would eventually become the American Southwest. The rings are younger than Velociraptor. They appeared while dinosaurs were still here, and those dinosaurs with no telescopes, no mathematics, no concept of a solar system, looked up at a sky in which Saturn was just a slow yellowish wandering star with no feature that distinguished it from anything else. They never saw the rings. For most of the billions of years before dinosaurs, Saturn was ringless. For most of the time after the rings appeared, nothing on Earth capable of recognizing them as rings had yet evolved. And for the relatively recent sliver in which human beings have existed, 300,000 years for Homo sapiens, 40,000 years for the painting on cave walls version, 400 years for the telescope version, the rings have been here, bright and present and going away. The rings are going away. That is not a distant abstraction or a scientific footnote. It is the central fact, the one that changes the meaning of every observation made of Saturn since 1610. The rings are losing mass continuously, shedding material into Saturn's atmosphere through a mechanism that was predicted correctly by a single scientist in 1986 and then sat in a journal paper, cited but not confirmed, for 32 years while the instruments needed to verify it were slowly built. That scientist is Jack Connerly. He has been at NASA's Goddard Space Flight Center in Greenbelt, Maryland since 1979. He is a planetary magnetosphere researcher. The invisible but consequential magnetic fields that envelop planets and shape everything that happens at their boundaries are his domain. He has led the magnetic field investigation on the Juno spacecraft orbiting Jupiter. He has participated in magnetic field studies of every magnetized planet in the solar system. He is not someone who sat with one idea for 32 years waiting for the world to notice him. He was busy with other things. But in 1986, he published something that nobody could yet confirm, and it sat in a drawer with his name on it until the instruments caught up. Here is what he found. Voyager 2 passed Saturn in August of 1981, returning images and data in extraordinary quantities. Among those images were photographs of Saturn's stratosphere, the upper atmosphere, above the visible cloud bands, showing 3 narrow dark bands circling the planet at northern mid-latitudes. They were narrow, dark, and without obvious explanation. The Voyager encounters had produced so much material, so many genuinely new discoveries, that 3 anomalous dark bands in a stratospheric image were easy to set aside. Most people working with the Voyager data moved on from them. Connerly spent 5 years with those bands. He mapped their latitudes precisely against Saturn's magnetic field geometry and found that the position of each dark band corresponded exactly to the latitude where Saturn's magnetic field lines, tracing outward from the planet, intersected the ring plane. Not approximately, not close, exactly, within measurement error. The rings and the atmosphere were connected by the magnetic field, and the connection was doing something. His explanation, published in Geophysical Research Letters in 1986, was this: ring particles are mostly water ice. Some of those particles, particularly the small ones, get electrically charged by ultraviolet radiation from the sun, or by plasma clouds produced when micrometeoroids hit the rings. Once charged, they no longer respond only to the gravitational balance that keeps ring particles in orbit. They also respond to Saturn's magnetic field, which curves inward toward the planet at the latitudes where the ring plane sits. For the charged particles, the balance of forces changes. Saturn's gravity pulls them down the magnetic field lines into the upper atmosphere. The water ice vaporizes. The water reacts with stratospheric haze and strips it away, leaving the atmosphere darker in reflected light at exactly the latitudes where the field lines emerge. 3 dark bands, precisely located, predicted by the geometry of the magnetic field. He named the mechanism ring rain. He gave it a rate the flow was substantial, he estimated, high enough to matter. And then, in the way that correct predictions sometimes sit in the scientific literature when the instruments needed to verify them do not yet exist, the paper was cited occasionally, referenced as interesting background, and not built upon in any significant way for decades. He was right. Everyone who read the paper carefully enough suspected he was probably right. The instruments to confirm it simply did not exist yet. They were being built. James O'Donoghue was a postgraduate student at the University of Leicester in 2011, working on Saturn's ionosphere, specifically the behaviour of a hydrogen ion called H3+. The ion is made of 3 protons and 2 electrons. When energised by sunlight, it glows in infrared light. The Keck 2 telescope on Mauna Kea in Hawaii, with its NIRSPEC spectrograph, is capable of detecting that glow across 400 million kilometres of space and resolving its variation across Saturn's disk. O'Donoghue's team was conducting a pole-to-pole survey of Saturn's ionospheric emissions on the night of April 17, 2011. What they expected was a relatively uniform equatorial glow, the kind of pattern Jupiter shows the planet glowing evenly across its equatorial regions in infrared. What they saw was something nobody had seen before, and something that Conony had predicted in a journal paper 25 years earlier. The ionosphere was not uniform, it was banded. Alternating regions of bright and dark, arranged in a pattern that mirrored, with extraordinary precision, the structure of the rings themselves. Where the rings were dense, the B ring, the A ring, the ionosphere, was dark. Where the rings had gaps, the Cassini division, the spaces between the named rings, the ionosphere, glowed. Saturn's magnetic field was mapping the rings onto the atmosphere in infrared light, and the map was detailed enough to trace individual ring structures. The mechanism was exactly what Conony had described. Charged water particles from the rings were flowing down the magnetic field lines, neutralizing the glowing H3+ ions, leaving dark lanes in the infrared emission. The dark bands in the stratosphere that Voyager had photographed in 1981, the ones Conony had decoded 5 years later, were being independently confirmed by a spectrograph that had not existed when he published. The shadow regions covered 30 to 43% of Saturn's upper atmospheric surface between 25 and 55 degrees latitude. Not a trace effect, not a signal at the edge of detection. A massive ongoing exchange between the rings and the planet, continuous, operating at scale, writing the structure of the rings in light and dark across an area larger than Earth's entire surface. O'Donoghue's team published the initial results in Nature in 2013. In the years following, he worked on the rate, not just the distribution, the quantity. How many kilograms per second were flowing from the rings into the planet? He returned to the Keck data, refined the analysis, accounted for the seasonal variation in solar ultraviolet hitting the rings, compared results against Conony's original estimates, and in December of 2018 published the full calculation in the journal Icarus. The number was between 432 and 2,870 kilograms per second. He reached for a comparison people could hold. An Olympic swimming pool worth of water drained from the rings into Saturn's upper atmosphere every half hour. At that rate, O'Donoghue said, the rings will be entirely gone in under 100 million years. He said this in the language of a press release from NASA's Goddard Space Flight Center, and then he said something else, a word that does not belong in scientific press releases, that scientists generally avoid because it implies something beyond the data, that he used anyway because it was the only word that fit. He said, "We are lucky to be around to see Saturn's ring system, which appears to be in the middle of its lifetime. Lucky, sit with what that word is doing there." O'Donoghue is not a writer who reaches for sentiment. He is a planetary scientist who published in Icarus. He chose that word with full awareness of what it implies and used it anyway, because the arithmetic of the situation had arrived somewhere that the technical vocabulary of planetary science does not quite reach. The rings appeared approximately 100 million years ago. They will disappear approximately 100 million years from now. We are here, at this moment, at almost exactly the midpoint. Not near the midpoint, not somewhere in the general vicinity. At the midpoint within the margin of error in measurements made of a structure 400 million kilometres away. Jack Connolly was listed as co-author on the 2018 paper. He had published his original prediction 32 years earlier, in 1986, and had watched it sit in the literature, unconfirmed, cited as background, while the instruments needed to verify it were built by people who were not yet born when he wrote it. When the 2018 paper was released, and reporters asked him about the confirmation of the ring-rain mechanism, he said, "That wasn't a complete surprise." 5 words, no elaboration. No speech about patience or persistence or the long arc of scientific vindication. Just 5 words from a man who had been right about something for 32 years and had now watched someone else's instruments confirm it. The restraint of that sentence is harder to sit with than any celebration would have been. It is the sentence of someone who has been waiting a very long time and is not going to perform the waiting for an audience. But the rate is only one piece of what arrived in the years around 2018. The other piece came from the final months of the Cassini spacecraft, and what it measured changed the age question from a debate into something close to a settled answer. Cassini arrived at Saturn in 2004. It spent 13 years in orbit, returning more knowledge about the Saturn system than everything that had come before it combined. It discovered active geysers on Enceladus erupting water ice from a liquid ocean beneath the frozen surface, making that small moon one of the most promising places to search for extraterrestrial life anywhere in the solar system. It resolved the structure of the rings in extraordinary detail, the shepherd moons Pan and Daphnis, 8 kilometres across, orbiting inside gaps in the A-ring and maintaining those gaps by gravitational herding, creating small rippled waves in the ring material as they passed. It measured the hexagonal storm at Saturn's North Pole, a geometric atmospheric feature so stable it has persisted for decades. It photographed Titan through multiple wavelengths, mapping the hydrocarbon lakes on that moon's surface. For 13 years it returned data. And then it ran low on fuel, and the mission team made a decision. Rather than let an uncontrolled spacecraft drift and potentially contaminate Enceladus or Titan moons that might harbour life, moons that a rogue spacecraft landing on could compromise for future study, they chose to end the mission deliberately. They aimed Cassini at Saturn itself. Between April and September of 2017, the spacecraft made 22 dives through the gap between the innermost ring and Saturn's upper cloud tops. The gap is roughly 2,000 kilometres wide, which sounds large until you account for the speed, over 30 kilometres per second, and the precision required to maintain the trajectory without clipping the rings on one side or descending too far into the atmosphere on the other. On each pass, the spacecraft was jostled by the separate gravitational pull of the rings, distinct from the pull of the planet. Scientists use those perturbations to calculate the ring mass directly for the first time, with the precision that only comes from being inside the system rather than observing it from outside. The result was published in January of 2019 in Science, led by Luciano Es of Sapienza University of Rome. The rings have a mass of roughly 40% that of Mimas Saturn's small, battered, crater-covered inner moon, about 400 kilometers across. In more concrete terms, the rings contain roughly half the mass of Earth's entire Antarctic ice shelf, spread across a surface area 80 times that of Earth. That is not a large number. Scientists had expected larger. The rings, as seen from Earth, look massive and permanent, as if they have been there as long as anything else in the solar system. The measurement said otherwise. A lower mass means a younger age. Because the rings accumulate contamination over time, dark silicate material from micrometeoroids embedding in the ice, and the rings are still largely bright and white. Young ice, not yet significantly polluted. The mass, the brightness, the contamination level, the loss rate, every number pointed in the same direction. The rings are young, they have not been there long, and they were not going to last much longer. On September 15th, 2017, Cassini transmitted its final data back to Earth at a rate of about 27 kilobits per second, slower than the connection on most phones. The signal travelled for 83 minutes at the speed of light before it reached the receiving dishes. By the time it arrived, the spacecraft that sent it no longer existed. Cassini had entered Saturn's upper atmosphere at over 30 kilometers per second and vaporized. Its instruments, its fuel tanks, the hardware that had been operating in the Saturn system for 13 years, dissolved into the planet it had spent a career studying. It is part of Saturn now, mixed into the upper atmosphere at whatever diffuse chemical concentration a spacecraft becomes when it burns up in a gas giant. The rings are there too, still orbiting, still present, still catching sunlight, still raining down into the ionosphere at 432 to 2,870 kilograms per second, flowing down magnetic field lines that Jack Conany mapped in 1986. The rate O'Donoghue measured accounts for rain the magnetic field mechanism. Cassini measured a second separate loss pathway, material from the innermost D ring spiralling directly into Saturn's equatorial atmosphere through a different process, at a rate that Hunter Waite and his team at the Southwest Research Institute calculated was enough on its own to drain the visible rings in 30 to 40 million years. Add the two mechanisms together, ring rain flowing down the magnetic field lines and the direct equatorial infall from the D ring, and the total loss rate is substantially higher than either measurement alone. The rings have less than 100 million years left, probably considerably less. The uncertainty in that number is real, and the script does not pretend otherwise, but the direction is not in question. The rings are going away. The rate at which they are going away is roughly the rate Conany predicted in 1986, sitting with 5-year-old Voyager images and magnetic field equations in an office in Greenbelt, Maryland. Now the question that the rate and the mass together forced into the open, where did the rings come from? For most of the time since Galileo's letter to the Duke of Tuscany, The assumption was that the rings formed alongside Saturn, that they were primordial, as old as the planet itself, assembled from the same disk of dust and gas that built everything else in the early solar system. This assumption was never universally held, but it was the default. The rings looked permanent because they had always been there in every record humans possessed. The Cassini measurements demolished that assumption. Rings this light, this bright, this uncontaminated, do not belong to a 4.5 billion year old planet. They belong to something much more recent. And something much more recent means something happened, an event, a specific event, that produced the rings within the last few 100 million years. The leading hypothesis for what that event was is the most extraordinary piece of this story. It was published in September of 2022 in the journal Science, led by Jack Wisdom, a professor of planetary sciences at MIT, a MacArthur Fellow, a man who has spent decades working on the mathematics of solar system dynamics, the chaotic long-term behaviour of planetary orbits and rotations. His team includes researchers from MIT, the University of California at Berkeley, the University of Arizona, UC Santa Cruz, and Wellesley College. What they found requires starting not with the rings, but with Saturn's tilt. Saturn rotates at a 26.7 degree angle relative to the plane in which it orbits the Sun. Earth is tilted at 23.5 degrees, the tilt that gives us seasons. Saturn's tilt is similar in magnitude, but has no obvious cause. For a long time, the best explanation was a gravitational resonance with Neptune. Saturn's axis precesses wobbles slowly, like a spinning top at nearly the same rate as Neptune's orbital period. The two planets were locked together, in a sense, across billions of kilometres, and that lock was what tilted Saturn and kept it tilted. But Cassini's grand finale measurements produced something unexpected. The spacecraft's precise mapping of Saturn's gravitational field allowed scientists to calculate Saturn's moment of inertia, how its mass is distributed between its core and its outer layers. And the moment of inertia showed that Saturn's axis was no longer inside Neptune's resonance. It was close to it, but it had escaped. Something had knocked it out. Wisdom and his colleagues ran orbital simulations forward and backward through time. They tested every combination of existing moons, every plausible instability in the current system. The existing moons, all 83 of them, including Titan with its fast outward migration and Iapetus in its distant inclined orbit, could not account for the escape from Neptune's resonance. The numbers did not work. So they added one, a moon that no longer exists. They named it Chrysalis. They estimated it was roughly the size of Iapetus, Saturn's third largest surviving moon, a body about 1,400 kilometres across. Not a small object, a world in its own right, with its own gravity, its own geology, its own orbital path. Their simulations placed it in an orbit between Titan and Iapetus, where it had been orbiting undisturbed for billions of years. Its gravitational contribution to Saturn's precession was the piece that had kept the planet in resonance with Neptune. Without Chrysalis in the sum, Saturn's axis would drift out of the resonance. With it, the system was stable. Then, somewhere between 100 and 200 million years ago, the simulations show Chrysalis drifting into a chaotic orbital zone. It had close gravitational encounters with Titan. It had close encounters with Iapetus. The interactions grew more extreme with each pass. And then Chrysalis came too close to Saturn itself. Saturn's tidal forces the differential gravity that pulls more strongly on the near side of any body than the far side tore Chrysalis apart. Most of its mass fell into the planet, but a fraction, enough, remained suspended in orbit. Over time, that suspended debris was ground down by collisions and by the steady abrasion of micrometeoroids, the fragments shattering into smaller fragments, the smaller fragments into grains, the grains sorted by orbital mechanics into a disk. The disk flattened further, and what remained was what Galileo saw in 1610. Wisdom named the moon after the stage of insect metamorphosis in which a caterpillar dissolves its own body inside a chrysalis and rebuilds it into something completely different. He said the moon was long dormant and then suddenly became active and the rings emerged. He allowed himself that sentence with the awareness that it was slightly poetic and the judgment that it was also accurate. This is a hypothesis. It must be said clearly and held clearly, this is not a confirmed observation. You cannot observe the past. You cannot go back 160 million years and watch Chrysalis come apart. What Wisdom and his colleagues showed is that the hypothesis is consistent with every measurement Cassini made, that it accounts for both Saturn's present tilt and the age and mass of the rings, and that no other explanation currently does that as cleanly. It is the best story the evidence supports. It is not the last word. But if it is right, and the scientific community's response suggests most researchers find it compelling, then the rings are not just temporary. They are ruins. The most recognisable structure in the solar system, the thing that makes Saturn Saturn, is the debris of a world that died. Every grain of ice in the A ring and the B ring and the C ring and the D ring, every particle from microscopic dust to house-sized boulders was once part of a body that had enough gravity to hold itself together, enough orbital momentum to pull Saturn slightly off its axis over billions of years, enough substance to be a full participant in the dynamics of a planetary system. And then the mathematics of orbital resonance caught up with it, and it came apart, and what is left is orbiting in pieces, arranged in a disk so flat that when it turns edge onto the Earth, it vanishes the way it vanished for Galileo in 1612. He thought Saturn had consumed its children. He was describing the right process in the wrong direction. What Saturn consumes is the rings themselves. That consumption is what Conony named in 1986. That consumption is what O'Donoghue measured in 2018. That consumption is what Cassini spent its final 22 orbits helping to quantify before it became part of the planet itself. The rings are falling into Saturn. They have been falling into Saturn since they formed. Every second they have existed has been a second of net loss. The particles that get charged by ultraviolet light or by micrometeoroid impact flowing down magnetic field lines into the ionosphere, vaporizing, reacting with the atmosphere, leaving the dark bands that Voyager photographed and Conony decoded in O'Donoghue. The rings are not static. They are a process. They are the ongoing slow dissolution of something that should not have existed in the first place, by the standards of a 4.5 billion year old planet that spent most of its existence without them. Now hold the arithmetic at its full length. Saturn has existed for 4,500 million years. The rings have existed for, at the outside, 400 million of those years. More likely, 100 million. That means the rings have been present for somewhere between 2 and 9% of Saturn's total age. If you compress Saturn's entire lifetime into a single calendar year, 4.5 billion years, folded into 365 days, the rings did not appear until somewhere in late November, probably December, and they will be gone before the new year. In that same compressed calendar, modern human astronomy, the 400 years from Galileo's first observation to the March of 2025 when Saturn's rings tilted edge onto Earth again and vanished temporarily from view occupies about 3 seconds. 3 seconds out of a year's worth of Saturn's history, during which the rings happened to exist and a species happened to build the instruments to understand them. The rings were not present for the first 4+ billion years of Saturn's life. They will not be present for the final billions after they drain away. In the small notch between those two absences, in the sliver of geological time when the rings existed, there exists an even smaller notch, the few 100,000 years in which a species with enough curiosity and enough mathematics and enough engineering to build a 10-meter telescope on a mountain in Hawaii looked up and noticed that Saturn looked different from everything else. And within that smaller notch, smaller still, the window in which the instruments were good enough to understand not just that the rings existed, but that they were temporary. That window opened in 1981 when Voyager 2 photographed the dark stratospheric bands. It began to close the moment Conony understood what those bands meant. It opened wider when O'Donoghue pointed the Keck spectrograph at Saturn in 2011 and found the rings written in infrared on the planet's atmosphere. It opened to its current width when Cassini dove through the ring gap 22 times in 2017 and returned the mass measurement that confirmed the youth of the rings and the shortness of what remains. We are in that window, not abstractly. Specifically, the understanding that the rings are temporary, that they are going away at a measurable rate, that the rate was first predicted by a man in Maryland staring at images from a spacecraft that has since left the solar system. That understanding is not old. It is recent. It is still being refined. The seasonal variation in ring rain has not yet been fully characterized. The chrysalis hypothesis is less than 4 years old. The mass measurement from Cassini's grand finale is 7 years old. This is not ancient knowledge. This is knowledge that arrived while most of the people currently alive were already alive. The specific weight of that is worth staying with. Conony, published in 1986, many people alive today were already born. The paper sat in the literature for 32 years. O'Donoghue's 2013 Nature paper, the one that confirmed ring rain from the Keck data, is recent enough that the researchers who published it are still early in their careers. The Cassini mission ended in 2017. Wisdom's chrysalis hypothesis is 2022. The understanding of the ring's temporariness is not settled history. It is a body of knowledge that is still being assembled by scientists who are still working from data that is still being analysed. And the thing being understood is ending, slowly in geological terms, at 430 to 2,870 kilograms per second in human terms. Both of those statements are true simultaneously. The rings are ending slowly enough that no human life will see any visible change. They are ending fast enough that precise instruments can measure it from Earth. What this means practically is that the D ring, the innermost, already the most depleted, will go first. The material there is already the thinnest, the most influenced by the equatorial infall mechanism Cassini measured. Then the C ring, less massive than the B. Then, last, the B ring, the most massive, the densest, the bright central band that gives Saturn its most recognisable feature. The Cassini division, the dark gap between the B and A rings, is not a ring, it is an absence, cleared by the gravitational resonance of the moon Mimas, and it will remain after the rings are gone, a gap with nothing on either side of it. Pan, the 8-kilometre moon orbiting in the Encke gap of the A ring, will outlast the rings that currently surround it. When the A ring drains away, Pan will still be there, a small moon in a cleared gap with nothing left to herd. After the rings are gone, Saturn will still be Saturn in every other way. Its magnetic field will continue. Its storms will continue. Its banded atmosphere and its polar hexagon and its dozens of surviving moons, Titan migrating steadily outward at 11 centimetres per year, Enceladus erupting water ice from its subsurface ocean, Iapetus in its distant inclined orbit, Mimas battered, and crater pocked at the inner edge of the system, all of it will continue. The planet will be billions of years old and will have billions of years ahead of it. It simply will not have rings. And if the chrysalis hypothesis is right, if the rings are indeed the debris of a moon that came too close, then Saturn has almost certainly been through this before. At 4.5 billion years old, with the gravitational heft to disrupt bodies that stray close enough, Saturn has probably captured and destroyed multiple objects over its lifetime. Each time a ring system forms. Each time the ring rain and the equatorial infall drain it away. The planet returns to its undistinguished ringless state, a gas giant like any other, and waits for the next moon or comet or asteroid to stray into range. The rings we see are not the beginning of Saturn's ring story. They are a chapter. There were probably chapters before, and there may be chapters after. But the chapters are separated by hundreds of millions of years of nothing, and no continuous civilization will watch one end and another begin. The next chapter, if it comes, will be observed by something we cannot imagine, using instruments that do not exist yet, with no knowledge of what was seen during this chapter, unless it has been preserved with a care that human institutions have not historically demonstrated, which means the Cassini data, the Keck observations, O'Donoghue's papers, Cononey's 1986 prediction, Wisdom's simulations of chrysalis tearing apart. These are the record, not just of what the rings look like, of what the rings are, of where they came from and how they are ending. If that record persists, then something in the future will know about these rings even after they are gone, the way we know about ice ages from sediment cores and mass extinctions from the fossil record. The rings themselves will leave traces, chemical signatures in Saturn's upper atmosphere, slight gravitational anomalies, perhaps isotopic records in the remaining moons. Something patient enough and capable enough could reconstruct what was here. But they will not see it. Here is what seeing it requires, in specific terms. It requires a planet in the habitable zone of a star with enough light to warm liquid water. It requires life arising on that planet, surviving long enough to develop complexity, developing enough complexity to produce curiosity, producing enough curiosity to build instruments, building instruments precise enough to resolve a disk of ice and rock at the distance of the outer solar system. It requires all of that to happen during the roughly 200 million year window when Saturn's rings exist at all, a window that is, on the scale of the universe's 13.8 billion year age, equivalent to a blink. That combination of requirements could have been met by something that arose on Earth 300 million years ago, before the rings existed. It could be met by something that arises on Earth 300 million years from now, after the rings are gone. The timing is the part that was not guaranteed. The timing is the part that happened to work out. Galileo was not guaranteed to be alive when the telescope was invented. He was. Cononey was not guaranteed to be at Goddard when Voyager returned its images. He was. O'Donoghue was not guaranteed to be pointing a spectrograph at Saturn on the night of April 17, 2011. He was. The instruments were not guaranteed to reach sufficient resolution during the lifetime of the rings. They did, barely, in the last few decades of a window that is 100 million years wide. Barely is not a small word in that sentence. Barely is the whole sentence. The Voyager 1 spacecraft, which made its closest approach to Saturn on November 12, 1980, is now approximately 24 billion kilometres from Earth. It crossed into interstellar space in 2012, the first human-made object to do so. It is travelling at roughly 17 kilometres per second. At that speed, it would take approximately 70,000 years to reach the nearest star. The images it returned of Saturn's stratosphere in 1980, the images that contained, buried in the data, the dark bands Colony would decode 5 years later, were transmitted at a time when the scientists who built the spacecraft could not yet know what the images contained. They sent the images home, they waited, they worked with what arrived. The dark bands were in the data before anyone knew to look for them. The ring rain was happening before Colony named it. The rings were going away before anyone knew they had arrived. This is the thing about the ring rain that is hardest to hold. It is not something that began when humans measured it. The process started when the rings formed, when chrysalis came apart, and the debris settled into a disk, and the disk began interacting with Saturn's magnetic field, and the charged particles began flowing down the field lines into the atmosphere. That was 100 million years ago, give or take. Every year of the ring's existence, every year, for 100 million years, has been a year of the rings becoming slightly less. The balance between orbital mechanics and gravitational pull shifting grain by grain toward the planet. The glow of H3+ ions in Saturn's ionosphere, which O'Donoghue's spectrograph detected on Mauna Kea on April 17, 2011, was there the night before. It was there a year before. It was there a million years before. It was there before the first human eye looked up at a night sky. The process does not need an audience. It does not pause between observations. The ring rain falls whether or not there is a spectrograph pointed at the ionosphere. The bands in the stratosphere were dark before Voyager photographed them, before Colony decoded them, before O'Donoghue confirmed them. The rings are not performing their disappearance for the instruments. The instruments are just catching up. In March of 2025, Saturn's rings tilted edge onto Earth again, the same geometry that made the companions vanish for Galileo in 1612, and briefly disappeared from view. Astronomers knew it was coming. It was tracked, predicted, announced months in advance. Telescopes pointed at Saturn during the window and recorded the moment. It will happen again in roughly 15 years, and again 15 years after that, as many times as the rings remain. The disappearances are temporary. The viewing geometry restores. The rings come back into view, until they do not. The final edge on tilt, whenever it comes, in tens of millions of years, will be followed by the rings gradually thinning, not tipping to reveal themselves from a new angle, just thinning. The D ring going quiet, the C ring losing its brightness as mass drains away. The B ring, the most massive, last to go, gradually becoming more tenuous, less reflective, less visible in smaller telescopes, then in larger ones, then in anything. And then Saturn, as it has been for most of its existence, a large gas giant with a slight tilt and dozens of moons and nothing else to distinguish it from a distance. The people who will see that transition, if there are people, if they are watching, will have descriptions of what came before. Data from Cassini, O'Donoghue's rate calculations, Colony's 1986 paper, If Such Things Survive. They will know what the rings look like. They will not see them. We are the ones who see them. Not in the vague collective sense of humanity having knowledge of something. Specifically, anyone who has looked through a small backyard telescope and found Saturn and seen the rings, not read about the rings, seen them, That specific moment when a planet stops looking like a bright dot and becomes something with a structure, something different from everything else in the eyepiece, that is a direct observation of a temporary structure that has been temporary for its entire existence and will be gone in geological terms shortly. The 400 years from Galileo's first confused observation to the present is not even a rounding error in the ring's lifespan. It is the entire span of human visual contact with them. Huygens decoded the geometry and published in 1659. He died in 1695, 36 years later, without knowing the rings were temporary. He knew their shape. He could not know their age. The instruments for measuring age did not exist in the 17th century and would not exist for 3 more centuries. Conolly knew the rings were losing mass when he published in 1986. He did not have a precise age because the mass measurement required Cassini's grand finale, which was 31 years away. But he had the mechanism. He had the dark bands. He had the magnetic field geometry. He had a rate estimate. He knew the rings were not static. He knew they were losing material. He knew the direction. He wrote it down and published it, and it sat in the drawer for 32 years. O'Donoghue had both the mechanism and the rate. He published in 2018 and chose the word lucky, and was correct to choose it, and probably did not fully anticipate how specifically correct it was. Wisdom published in 2022 and named the dead moon, and was careful to present it as a hypothesis, and was also probably right. Between Galileo in 1610, who saw something he could not, Name and Wisdom in 2022, who named something he could not, directly observe there is 4 centuries of humans trying to understand what Saturn is and what the rings are and where they came from and how. Long they will last. The understanding is not complete. It may never be complete in the sense of confirmed beyond revision. But the outline is clear. The rings are young. They are going away. They came from something that is gone. They will go the same way. And the specific improbability of the 400 years of that understanding fitting inside the 200 million year window of the ring's existence, of the instruments arriving in time, of the Voyager images containing the dark bands before anyone knew to look for them, of the Keck telescope being built before the rings had drained to invisibility, of Cassini arriving at Saturn in 2004 with enough time to complete its grand finale before the rings changed significantly from what Galileo saw, that improbability is not something the physics accounts for. The physics accounts for the rate, the chemistry accounts for the mechanism, the orbital dynamics account for the origin. None of it accounts for the timing of the understanding. That part is the part that sits outside the equations. The rings were going away before anyone knew they were there. The understanding arrived while there was still something to understand. Galileo saw something real and could not name it. He wrote to a duke that he was surprised and confused and had no words for it. He was right that there were no words for it. Not because the phenomenon was nameless. Huygens gave it a name 45 years later, and Conolly gave the process a name, and O'Donoghue gave the rate a number, but because the full statement of what it is requires saying all of it at once. The rings are the ruins of a moon that died 160 million years ago, arranged in a disk 10 metres thick and 280,000 kilometres wide, orbiting a planet that is 4.5 billion years old and was ringless for most of its existence, and they are draining into that planet at the weight of an Olympic pool every 30 minutes, and they have been doing this since before the first human looked up at the sky, and they will continue doing it long after the last one does, and no one arranged for it. Conolly in 1986, working with 5-year-old data from a spacecraft that is now in interstellar space. O'Donoghue on April 17, 2011, pointing a spectrograph at Saturn and finding something he was not looking for. Cassini transmitting its final data at 27 kilobits per second on September 15, 2017, 83 minutes before the signal ended because the spacecraft had ceased to exist. Wisdom running simulations backward through time until a moon-shaped hole in the orbital mathematics showed him where Chrysalis used to be. Each of them found something in the window. Each of them reported what they found. The findings accumulated into an understanding that now sits in the literature, in journals, in datasets, archived at Goddard and JPL and the University of Reading and MIT, available to anyone who knows where to look. The rings are going away. 430, 2 to 2,870 kilograms per second. An Olympic pool every half hour. A moon's worth of debris slowly becoming a planet's upper atmosphere. The conversion driven by magnetic field lines that have been doing this work since before the first Cretaceous dinosaur, the work continuing tonight, the work continuing now, the glow of H3+ ions in Saturn's ionosphere, writing the structure of the rings in infrared across an area larger than Earth, visible to any instrument sensitive enough to look, visible whether or not any such instrument exists. The instrument exists, the understanding is incomplete, and the understanding is here. The window is open, and the window is closing, and the closing takes 100 million years, and we are inside it, the only minds that have ever been inside it. At the only moment in 4.5 billion years when a species on this planet was capable of looking at Saturn and knowing what it was seeing, and knowing that what it was seeing was going away, and knowing, with the precision of a spectrograph on a mountain in Hawaii, exactly how fast. Galileo wrote that he did not know what to say. He had 400 years of successors who figured it out. What they found was this: the most beautiful thing in the solar system is temporary, has always been temporary, was temporary before anyone knew it was there, and the window in which anyone could know it and see it simultaneously is the window we are in right now. That is what the rings are. That is what we are. The numbers have a way of doing something to a person if you let them sit long enough without moving past them. 430, 2 to 2,870 kilograms per second. That range is not an abstraction. It is not a rounding. It is the actual measured uncertainty in the flow rate of material leaving Saturn's rings, derived from observations made with a specific instrument, the NIRSPEC spectrograph, on the Keck 2 telescope on specific nights, analysed by a specific team, published in a specific journal in December of 2018. The range exists because the flow is variable. Because Saturn's seasons change how much ultraviolet light hits the rings. Because the rate of micrometeoroid bombardment that charges the ring particles is not constant. Because the ionosphere itself varies with solar activity. The lower bound 432 kilograms per second is not the optimistic case. It is not the number that lets you feel better about the rings. Even at 432 kilograms per second, sustained across the roughly 100 million years the rings have left, the math resolves in the same direction. The rings drain. The planet absorbs them. What is left is a gas giant orbiting a middle-aged star, indistinguishable from thousands of others we have already catalogued in other solar systems. At the upper bound, 2,870 kilograms per second, the timeline compresses. The rings have tens of millions of years left, not 100 million. The difference between those two outcomes, from where we stand, is zero. We will not see either ending. Our descendants, in any biological sense of the word, will not see either ending. The ending is not the point. The rate is the point. The rate tells you not just when, but how the specific texture of what it looks like when something this large, this bright, this visually dominant disappears. It looks like nothing from a human vantage point. It looks exactly like what it looked like the year before, and the year before that, and the year before that. The loss is real and the loss is invisible, and both of those things are true simultaneously. This is something Conolly understood before O'Donoghue measured it. When he published in 1986, he was not describing a catastrophe in progress. He was describing a process so slow it could not be perceived directly, that could only be detected through the signatures it left the dark bands in the stratosphere, the pattern of ionospheric glow, the alignment of those features with the magnetic field geometry. The process had been running for 100 million years before anyone detected it. It will run for tens of millions of years after the last paper about it is published. The detection is not the event. The detection is just the moment the instruments became good enough to see what had always been happening. There is something specific about that, about the relationship between an ongoing process and the moment of its detection that keeps returning when you spend enough time with this material. It is not unique to Saturn's rings. Plate tectonics was happening for billions of years before anyone understood what continents were doing. Stellar evolution was following precise mathematical rules long before anyone derived those rules. The universe does not wait for its processes to be named before it runs them. But with Saturn's rings there is a particular sharpness to it, because the process being detected is also the process of destruction, and the detection happened so late in the destruction's timeline that the two things, the understanding and the ending, are now neighbours in the same geological moment. Conolly detected the process in 1986. At that point, the rings had already been losing mass for approximately 100 million years. They had perhaps another 100 million years to go. He was exactly at the midpoint of the destruction when he named it. And yet if the instruments had not been there, if Voyager 2 had not returned those stratospheric images in 1981, if Conolly had not spent 5 years mapping the band positions against the magnetic field, if the Keck Observatory had not been built with a specific resolution needed to detect H3+ emissions in Saturn's ionosphere, the destruction would have continued at exactly the same rate. Not slowed by ignorance, not accelerated by understanding, simply proceeding as it always had, indifferent to whether anyone had named it. The naming matters only to the namers, which is to say it matters enormously, and only to us. There is a specific detail about the ring structure that most treatments mention briefly and then move on from, and it deserves more time than it usually gets because it changes the way the loss feels when you understand it precisely. The rings are not a single object. They are a system named, mapped, differentiated, each with distinct properties that reflect distinct histories within the overall disk. Starting at Saturn and moving outward, there is the D ring, the C ring, the B ring, then a gap, the Cassini division, then the A ring, then the narrow F ring, then the G ring, then the E ring, which is maintained by the geysers of Enceladus, spraying ice particles into space. Each ring has different density, different particle size distribution, different optical depth, how transparent it is to light passing through it. The B ring is the most massive, the most opaque, the most visually prominent. The D ring, closest to Saturn, is the most tenuous, barely detectable in most observations, already so depleted that in some models it is closer to an end state than a ring in its prime. The structure of the rings is not static even at timescales shorter than their geological decline. It is dynamic in ways that Cassini revealed in extraordinary detail. Pan, the 8-kilometre moon orbiting in the Encke gap of the A ring, produces gravitational Wakes ripples that propagate through the ring material on either side of it as it passes, dying out over distances of hundreds of kilometres. Daphnis, even smaller at about 8 kilometres but orbiting in the narrow Aquila gap, produces waves with a distinct kinking shape at the gap edges, the ring material piling up, and being drawn out in a pattern that looks almost biological, like a coastline responding to a tide. The shepherd moons of the F-ring, Prometheus and Pandora, orbiting just inside and just outside the narrow strand gravitationally, sculpt it into a braided, knotted structure that Voyager first photographed and that scientists initially thought violated orbital mechanics before they understood the shepherd moon effect. These are not decorative details. They are the rings being active. The rings are not a painting. They are a physics problem being solved in real time, continuously, with every particle negotiating its orbit against the competing pulls of Saturn's gravity, the Sun's radiation pressure, the magnetic field, the gravitational perturbations of dozens of moons, and the collisions with other particles and with incoming micrometeoroids. The structure you see in a photograph of Saturn, the clean bands, the dark gaps, the bright B ring, the faint outer rings, is a snapshot of a system in constant motion, balanced in a configuration that will look almost identical in 1,000 years and radically different in 10 million. And within that constant motion, some particles are always being lost. Not most, not dramatically. A small fraction, continuously the ones that get charged by solar ultraviolet or by micrometeoroid impact at the wrong moment, in the wrong part of the ring, where the magnetic field geometry tips the balance from orbit to infall. Those particles leave. They flow down the field lines, they become rain. And the rain has been falling since the disk formed, so the disk is slightly less today than it was yesterday, and slightly more today than it will be tomorrow, and the trajectory has only one direction. Connolly saw this in 1986 in 5-year-old Voyager images. O'Donoghue confirmed it in 2011 from Mauna Kea. Cassini quantified the mass in 2017. The loss is real, and it is specific, and it is happening in the D ring right now at a rate that means the D ring will be the first to go, not in a geological eye blink, not tonight, but first. When the D ring is gone, Saturn will still have rings. The C, B, A, F, G and E rings will still be there, still catching sunlight, still producing the recognisable silhouette. But the D ring will be absent, and something will be gone that was present for the entire duration of human telescope astronomy and that no future observer will see. The D ring has been there every time anyone has looked. The next thing we build after the Cassini mission, whatever the next Saturn orbiter is, whenever it launches, whenever it arrives, may find a D ring significantly more depleted than what Cassini measured. Not gone, but going, visibly. This is what geological time looks like when the instruments are precise enough to resolve it within a human lifetime. Not the ending, the slope. The Enceladus detail is one that deserves its full weight in this story, not as a digression, but as a parallel that makes the main thread stranger. When Cassini confirmed in 2005 that Enceladus was erupting geysers of water ice from its south polar region, it resolved a mystery about Saturn's E-ring. The E-ring, the outermost of the main ring structures, a broad and diffuse halo of tiny ice particles, had always been anomalously bright for its distance from Saturn. Ring particles at that distance should be dark, contaminated by billions of years of micrometeoroid impacts and solar radiation processing. The E-ring was fresh, its particles were being continuously replenished. Enceladus is the source. The geysers erupt water ice from the subsurface ocean, a liquid water ocean beneath 6 kilometers of frozen crust, kept liquid by tidal heating from Saturn's gravitational flexing of the Moon as it orbits in a slightly elliptical path. The erupted particles enter orbit and become the E-ring. Enceladus is, in other words, manufacturing ring material at this moment. It is the one part of Saturn's ring system that is being actively replenished rather than simply losing mass. But this replenishment is also a loss. The E-ring is also raining into Saturn along a different set of magnetic field lines. Conony, in the 2018 paper, noted the glowing band in Saturn's southern hemisphere at the latitude corresponding to where Enceladus's magnetic field line intersects the planet. He had identified it in the 1986 paper from the same Voyager image, a narrow dark band slightly separate from the main ring rain bands, corresponding to the E-ring and Enceladus. He said, when reminded of it in the context of the 2018 results, that wasn't a complete surprise either. What Enceladus is doing, essentially, is running a loop. It takes liquid water from its subsurface ocean, driven by tidal heating from Saturn's gravity, erupts it as ice particles into orbit. Those particles become the E-ring, and the E-ring rains back into Saturn. Saturn's gravity is both the engine of the eruption and the drain that the erupted material flows into. The Moon is spending itself to maintain a ring that is returning to the planet that is destroying the Moon. Enceladus will outlast the rings it feeds. The tidal heating that powers its geysers will continue as long as it remains in its slightly elliptical orbit. The subsurface ocean will persist, the geysers will erupt, but the material they produce will continue to rain into Saturn, and eventually, in timescales far beyond the main ring system's remaining life, the E-ring will also drain, and Enceladus will erupt into empty space, its water ice particles looping out of the geysers and finding no ring to join, drifting in orbits until they too are drawn down by the planet's magnetic field and gravity. The reason this parallel matters is what it says about Saturn's relationship to the things it creates and destroys. Chrysalis was drawn close enough to be torn apart and became rings. The rings rain into the planet. Enceladus feeds the E-ring, and the E-ring rains into the planet. The planet takes everything that comes close enough, breaks it, incorporates it, adds it to its atmosphere, moves on. Saturn is not indifferent. Indifference implies the possibility of attention. Saturn is simply gravitational. It does what gravity does at the scale of a planet with 95 times Earth's mass. It accumulates. It has been accumulating for 4.5 billion years. The rings, chrysalis, the ring rain, the Enceladus geysers, these are all part of the same process. Saturn gathering itself. There is a question that the reporting kept encountering, and that the published papers approach carefully without quite landing on it directly. It is not a physics question, it sits just outside physics. The question is this: what do you do with the knowledge that you are inside a window? Not in the abstract philosophical sense. Practically, James O'Donoghue published his paper in December of 2018, used the word lucky, and then continued his career. He moved from NASA Goddard to JAXA, the Japanese Space Agency, then to the University of Reading. He makes animations of Saturn's ring decline that have been viewed millions of times. He gives talks. He publishes further papers. He is doing, in other words, what scientists do. He found something, reported it, and continued finding things. Jack Conony, after being listed as co-author on the paper that confirmed his 32-year-old prediction, continued his work on Jupiter's magnetic field with the Juno mission. He has not, as far as the published record shows, given any extended public statement about what it felt like to be right for 3 decades before the instruments caught up. The 5-word response that wasn't a complete surprise is the only public record of his reaction that the reporting could find. he has continued working. Jack Wisdom, after publishing the chrysalis hypothesis in 2022, noted that it would have to be examined by others, that it was a pretty good story, but like any result it needed independent scrutiny. He said this with the measured caution of a scientist who knows that a compelling hypothesis is not the same as a confirmed result, and who has spent enough time in planetary dynamics to know that compelling hypotheses have been wrong before. Each of these scientists found something in the window and reported it and kept working. The knowledge that they were documenting something temporary did not appear to produce in any of them a paralysis or a heightened existential register. It produced more papers, more refinements, more attempts to narrow the uncertainty in the numbers. This is, on reflection, the correct response. Not because the existential dimension of the discovery is unimportant. O'Donoghue's use of the word lucky suggests he felt it, but because the way you honour a temporary thing you have found is to understand it as completely as possible before it is gone. You measure it. You refine the measurement. You test the hypotheses. You build the next instrument. You send the next mission. The next mission to Saturn does not yet exist in confirmed form. There have been proposals. The scientific community has discussed what a Saturn orbiter successor to Cassini would study, what instruments it would carry, what questions it would be designed to answer. The ring's remaining lifetime is long enough that a future mission would find them still present, still losing mass, still raining into the ionosphere. But the D ring will be thinner. The C ring will be less massive. The loss rate can be remeasured with better instruments. The seasonal variation can be fully characterized. The chrysalis hypothesis can be tested with improved gravitational mapping of Saturn's interior. The understanding is not finished. The window is still open. The work that fills the window is the work of people sitting at instruments on mountains and in mission control rooms and at desks with old data, looking for the thing nobody has named yet. Connolly in 1986 was doing that. He had no assurance that what he was finding would survive peer review, let alone be confirmed 32 years later. He was doing the work that the work required. That is what the window looks like from inside it. Not a vista, a desk, images, equations, a pattern in the stratospheric data that does not match the expected distribution. 5 years of mapping band positions against magnetic field geometry, a paper submitted to a journal, a result that sits in the literature, cited occasionally, waiting for better instruments. Saturn has been observed continuously by human-made spacecraft for 46 years. Voyager 1 in 1980, Voyager 2 in 1981, Cassini from 2004 to 2017. The gap between Voyager and Cassini, 23 years, is the longest we have gone without a spacecraft at Saturn since the Saturn exploration era began. During those 23 years, the ring rain continued. The particles flowed down the field lines, the dark bands persisted in the stratosphere. No one was there to watch, but the process ran. This is a fact about the difference between observation and occurrence. The Voyager flybys were not visits to a static exhibit. They were snapshots of a process that continued before them and after them. The Cassini mission was not a 13-year pause in Saturn's evolution. It was 13 years of that evolution being recorded. The 23 years between Voyager and Cassini were 13 years of ring rain that nobody measured. An Olympic pool of water every half hour for 23 years, unwitnessed, not uneventful. Unwitnessed, when Cassini arrived in 2004 and began its orbital survey, the rings were slightly less massive than when Voyager passed through. Not noticeably, not in any way that would register in a casual observation, but less. The accounting was already in motion. The total mass was slightly lower. The D-ring was slightly more depleted. The flow rate was steady. If there is a mission after Cassini, when there is a mission after Cassini, the rings will be slightly less massive again. The slope will be measurable. The instruments of a future mission will be able to compare their mass measurement against Cassini's 2019 result and see the difference. The difference will be small. It will be real. It will be the slope made visible across a human-scale time gap, the geological loss rate compressed into the span of an instrument's operational life. That comparison Cassini's measurement against a future mission's measurement will be the closest any human instrument ever gets to directly observing the ring's decline. Not the ending, not the dramatic thinning of the final millions of years, but the slope. The rate made real not as a calculation, but as a difference between two numbers taken at two times by two spacecraft a few decades apart. Someone will calculate that difference. Someone will publish it. And it will confirm again what Canoni predicted in 1986. The rings are losing mass. The mechanism is real. The direction is irreversible. That future scientist, whoever they are, whatever mission they are working with, will be standing in the same window that Canoni stood in, and O'Donoghue and Wisdom. The window will still be open. The rings will still be there, still bright, still catching sunlight, still the most visually distinctive structure in the solar system. And the future scientist will look at the number, the mass, slightly lower than Cassini measured, and will understand, with the same precision that O'Donoghue understood it in 2018, that they are lucky to be there. The Cassini division deserves a specific moment in this account, because it is the detail that contains, in miniature, the whole story of Saturn's ring system in a way that nothing else quite does. The Cassini division is the dark gap between the B ring and the A ring. It is about 4,800 kilometers wide. From Earth, it appears as a dark band separating the two brightest parts of the ring system. Giovanni Cassini observed it in 1675 with a telescope at the Paris Observatory 40, 5 years after Huygens published Systema Saturnium, 35 years after Galileo's death. He thought it was empty, an absence in the ring structure, a dark void between two bright bands. It is not empty. It contains ring material tenuous, dark, but present. What it is cleared. The moon Mimas, orbiting Saturn at a specific distance, exerts a gravitational resonance on ring particles in the region that would correspond to the Cassini division. Any particle that drifts into that orbital zone gets perturbed repeatedly by Mimes's gravity at the same point in each orbit, and those repeated perturbations add up over time into an eccentricity large enough to send the particle out of that zone. The zone is swept clear, not empty, but depleted by the ongoing work of a gravitational resonance operating over millions of years. What the Cassini division is, in other words, is a gap made by a moon's gravitational influence, maintained by the continued presence of that moon, and destined to outlast the rings that define its edges. When the B ring and the A ring drain away, when the ring rain has done its work, and the equatorial infall has done its work, and the mass is gone, the Cassini division will remain. Not as a gap between rings, just as a region of depleted space in Saturn's orbital neighbourhood, slightly darker than its surroundings, still cleared by Mimes's resonance, the ghost of a structure that no longer exists. Mimas will still be there, the resonance will still be operating, the clearing will continue even after there is nothing left to clear. The mechanism will outlast its own context. This is what remains when a ring system drains away, not nothing. The gravitational architecture persists, the moons persist, the magnetic field persists, the resonances persist. What disappears is the material of the ice, the debris of chrysalis, the particles that have been negotiating the balance between orbital velocity and gravitational pull for 100 million years, and are slowly, continuously losing that negotiation. And Mimas crater pocked, battered, looking in photographs startlingly like the Death Star, from a certain angle will orbit in the cleared region that used to be the Cassini division for billions of years after the rings are gone. A moon maintaining a gap with nothing to gap. The structure of the loss preserved in the continued motion of the bodies that caused it. Giovanni Cassini, who observed the division that bears his name in 1675, never imagined that a spacecraft would one day be named after him, would orbit Saturn for 13 years, would measure the mass of the rings he had studied from Paris through a refractor telescope, and would finally destroy itself in Saturn's atmosphere as its last act. He was a careful observer, a skilled mathematician, a man who correctly determined the distance from Earth to the Sun using observations of Mars. He watched Saturn for decades. He found the Cassini division. He found 4 of Saturn's moons, Iapetus, Rhea, Tethys, and Dione. He did not know the rings were temporary. He had no way to know. He saw what his instruments showed, and his instruments showed a beautiful and apparently permanent structure. This is the condition every observer of Saturn has been in until extremely recently. Galileo, no understanding of the structure. Huygens, understanding of the shape, no understanding of the age or temporariness. Cassini, the division, the moons, no understanding of what the division's clearing mechanism meant for the ring's future. The astronomers of the 18th and 19th centuries mapping the ring structure with increasing precision, naming the A and B and C rings, discovering the Encke gap, improving the measurement of the Cassini division, no understanding that what they were mapping was a system in the middle of its disappearance. The understanding of temporariness is 40 years old at the outside. Conony's 1986 paper is the beginning of it. Before 1986, the ring's disappearance had not been described in the specific mechanism-based, rate-estimated terms that constitute scientific knowledge of a process. After 1986, it had been imperfectly, without confirmation, but named and described and given a rate. 400 years of observation of Saturn's rings, 40 years of understanding that the rings are going away. The first 360 years of human visual contact with the rings happened in ignorance of their temporariness. The last 40 years have happened in that knowledge, and the knowledge has not made the rings look different. They look exactly the same as they did to Huygens, to Cassini, to the 19th century astronomers with their great refractors, to any child who looks through a backyard telescope on a clear night and finds them for the first time. They look permanent. They look as if they have always been there and will always be there. That is the specific quality of the improbability. The knowledge and the appearance do not match, and the knowledge is right, and the appearance will be right for longer than any human civilization will last, and both things are true. The full statement of what the rings are, held without flinching, goes like this. A planet formed 4.5 billion years ago in the gravitational collapse of a disk of gas and dust around a young star. The planet accumulated moons. It settled into its orbit. It was ringless for most of its existence, a gas giant like Jupiter, distinguished by its size and its magnetic field and its storm systems, but not by any visual feature that would make it remarkable from a distance. Somewhere between 100 and 200 million years ago, a moon, probably Iapetus-sized, probably in an orbit between Titan and Iapetus, probably having orbited stably for billions of years, became gravitationally unstable. It drifted too close to the planet. The planet's tidal forces tore it apart. Most of its mass fell into the planet. A fraction remained in orbit, and over time became a disk of ice and rock. The disk formed a ring system. The ring system has been losing mass since it formed through two main mechanisms: ring rain, driven by the interaction of charged ring particles with Saturn's magnetic field, and direct equatorial infall from the innermost ring. The total loss rate is between 432 and 2,870 kilograms per second at minimum, higher when both mechanisms are combined. At that rate, the rings will be entirely gone within approximately 100 million years, probably sooner. During most of the rings' existence, nothing capable of observing them existed on Earth. The first species capable of building a telescope appeared approximately 300,000 years before the rings will vanish. The first individuals capable of understanding what they were looking at appeared about 400 years ago. The first individual capable of understanding that the rings were temporary and measuring how temporary appeared about 40 years ago. The window in which the rings exist, a species exists, and that species understands the temporariness of the rings, is currently open. It has been open for 40 years. It will remain open for approximately 100 million more years before the rings close it from the outside. Nothing about this window was guaranteed. Everything about it is specific. The people who found the edges of the window, Conony naming the mechanism, O'Donoghue measuring the rate, Wisdom naming the dead moon, were working at desks and telescopes with specific data, publishing in specific journals, building and understanding piece by piece, with no guarantee that the pieces would fit. The pieces fit. The picture they make is of something ending slowly, in full view of the only minds that have ever existed that were capable of knowing it was ending. The minds look up, the rings are there, the loss is real, and it is invisible, and the instruments can see it, and the instruments are here and will be here, and the work continues. Conony's 5 words, that wasn't a complete surprise, carry the whole of it, not the drama of it, the weight of it, the specific gravity of being right about something for a very long time, watching better instruments confirm you, continuing to work. The restraint of that response is not modesty, it is precision. He was describing his emotional state with the same accuracy he brought to the magnetic field geometry in 1986. It was not a complete surprise. It was exactly what the equations had always said it would be. The equations have always said the rings are going away. They are going away. Everything else, Galileo's confusion, Huygens' geometry, Conony's dark bands, O'Donoghue's swimming pool, Wisdom's dead moon, Cassini's last transmission at 27 kilobits per second is the record of how long it took and what it cost, and who was paying attention while the rings quietly, continuously, at the weight of an Olympic pool every half hour, became something that will one day not be there. That record exists. We made it.